Hello, ladies and gentlemen. Today we are going to do electron configurations. This is a difficult topic. You may need to rewatch this video. You might have questions. It's okay. This is the electron configuration chart. If you have a paper copy, go ahead and get this out and fill it in. You may have already done it from what I gave you yesterday. Sorry, had to do that to get my pen back. This is just a chart telling us how electrons are filled into these orbitals or energy levels. You should write this down. So you have all the S's first, then P's, then D's, then F's, and then the different energy levels go across. So the way this is filled and your arrows, you're going to draw some arrows in here, and the arrows are going to tell us exactly what order to go in. So first we go through 1S. When you get done with one line, you're going to go straight to the next line. 2S. Then our third line is going to go through 2P and 3S. Next we have 3P and 4S. You should be drawing these too. Next we have 3D, 4P, 5S. 4D, 5P, 6S. 4F, 5D, 6P, 7S. Next we have 5F, 6D, 7P, and that is all of the known elements so far. Okay, so those arrows again tell us what order the electrons fill in. Electron configuration is a method of indicating the arrangement of electrons about a nucleus. The number in front of the letters indicate the energy levels. The number is called the principal quantum number. So 1s has a quantum number of 1. 6p has a quantum number of 6. The letter indicates the shape and type of orbital. S is a sphere. P is like two ovals next to each other. They're just different shapes that can hold different electrons. Each shape or type of orbital has a certain number of spaces to hold electrons. So an S has one orbital, can hold 2 electrons. P has 3 orbitals, can hold 6 electrons. D has 5 orbitals, can hold 10 electrons. F has 7 orbitals, can hold 14 electrons. Now, since we're not drawing all those circles, the way we draw it is simply with just lines. Sometimes, like on this, your homework in this computer later, you will see boxes. So it can either be 2 lines or 2 boxes. Each one of these is 1 orbital. So S has 1 orbital, it has 1 line or 1 box. P has 3 orbitals, so it has 3 lines or 3 boxes. D has 5 orbitals, so it has 5 lines or 5 boxes. 7 would have 7 lines or 7 boxes. Okay? Write this also on your sheet of paper. There are 3 rules that control where electrons are in an atom. As we discussed previously, electrons are placed in energy levels. Today we will learn a more accurate way to describe electrons' notation. There are 3 rules that control where electrons are in an atom. The Aufbau principle, saying that the lower energy levels are filled before the higher ones. The Pauli exclusion principle, which is an orbital can contain no more than 2 electrons with an opposite spin. So each box or line can hold up to 2 electrons. One is going up and the other is going down. And in Hund's rule, all of the orbitals of the sublevel fill with electrons of the same spin before we add any of the opposite spins. So you'll notice we start here with lithium, beryllium. Here's where we start. Boron, then we have carbon, nitrogen. Notice we're adding them all going up first, and then to add our next electron for oxygen, it goes down. And then we go down again for fluorine, and finally down the third time for neon. In English, so all three of those in English. The electrons are lazy. They like to go from the bottom to the top, lowest energy level first. Orbitals only hold 2 electrons, and electrons do not like to share orbitals. So we have those 3 rules. Which rules are being broken? So for 1s, for number 1, we have 1s, and there's one going up and then one going down. Then 2s, one going up, one going down. Then 2p, this is incorrect right here, this arrow. It should be here instead. Now, what rule tells us that they should go up first and then down? That is Hund's rule. Next, we have 1s, which is up, down, 2s, up, down, 2p, up, down, up, down, up, down, 3s. So there's our mistake right there. And the principle tells us that the lowest should be filled first. That is the Aufbau principle. Number 3, we have 1s, up, down, 2s, up, down, 2p, up, down, up, down, up, down. Then 3s, they're both going down. So this should be they're both going up. The second one should be going down. And that is our last rule, Pauli's rule, where they should have opposite spins. Okay. So now we're going to write orbital diagrams on our own. This is the way, the rules, the order that you do things. Determine the number of electrons to be represented. Start with the 1s orbital and move through the arrows that we drew. For each orbital, determine how many lines or boxes to draw. Use the rules to fill the orbitals with electrons. The sum of the arrows should equal the total number of electrons. Here we go. We have 3 practices. This is how we would do it if we were in person. So we have oxygen first. Oxygen has 8 electrons. Okay. You need this sheet of paper that you have everything written on. Make sure you have it out. Okay. So we're going to start at our first arrow. We have 1 line because we have 1s. S tells us it's 1 orbital, so that means we have 1 line. Okay. Each line can hold 2 electrons, so we have one going up and then one going down. That leaves us with 6 electrons to place. Going to our next arrow, we have 2s. Same thing, can hold 2 electrons, one going up, one going down. That leaves us with 4 electrons to place. After our second arrow on our other sheet that you have next to you, we have 2p. Now P is obviously a different letter than S. And what that P means is that there are 3 orbitals now. So we need 3 lines. We have 4 electrons to place. So we go 1, 2, 3. And then our 4th one comes back to the beginning and points down. And that should be all of our electrons. Things you can check. Make sure these numbers down here, the orbitals, follow your arrows, follow the order, 1s, 2s, 2p. And then make sure your number of arrows matches your number of electrons that you started with. 1, 2, 3, 4, 5, 6, 7, 8. We're good. Our next example is magnesium. Magnesium has 12 electrons. Okay. Same thing, we're going to start with 1s. S has 1 orbital, so 1 line. Goes up, then down. Now we have 10 electrons. Next arrow, it goes to 2s. So 2s goes up, down. 8 electrons left to place. After 2s is 2p. P's get 3 lines. So we go 1, 2, 3, 4, 5, 6. 8 minus 6 is 2. After 2p, my next arrow tells me 3s goes up, then down. Okay. Make sure these are in the right order. Following your arrows. 1s, 2s, 2p, 3s. And then count up to 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Next we have chlorine. Chlorine has 17 electrons to place. Okay. Same order. Start all over, starting with the 1s. Follow our arrows. S is 1 line. It gets an arrow going up, then an arrow going down. Next we have 2s, which is 1 line, an arrow going up, an arrow going down. Following our arrows, we have 2p. P's get 3 lines. Up, 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 down, down, down. Just realized I forgot to subtract all that. So our first one, we have 15 left. Second one, we have 13 left. Minus 6 is going to be 7 left. After 2p comes 3s. So it has 1 line because it's an S. Goes up, then down. 5 left to place. After 3s comes 3p. P's get 3 lines, 3 different orbitals. 1, 2, 3, 4, 5. Let's check. Our orbitals go in the order of our arrows. 1s, 2s, 2p, 3s, 3p. Okay. Then we need to count our number of arrows to make sure they're the same as our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We are good. Now these look a little different, so you should have written all of that down. These look a little different on the computer because we're virtual. They look like this, okay? And I'm going to get out of present mode now so I can show you how you would do this on your homework, Okay, so you're going to have these paired and unpaired electrons, and you're going to have oxygen up here. So oxygen has 8 electrons. I'm going to write that down here. And then for your homework, you're going to take and click and drag, filling them as your chart says. 1s, 2s, then you have 2p. So that's 2, 4. Well, let's try here. Ooh. Okay. Now that's 2, 4, 5, 6, 7. We need one more. So instead of this single electron, we're going to need a double. All right. And that's oxygen. Now over here in the corner, it asks you how many unpaired electrons are there. So how many are just solo electrons? And you're going to click in there and type in your answer. All right. For our next one, we're going to draw the orbital diagram for a neutral magnesium atom. So here's magnesium. So we've already done this, so I'm just going to show you how it would look on this diagram. So again, we've already done this, and magnesium has 12. So you should have that written in front of you. I'm just going to click and drag them over there. You should have all of the 3s filled. How many unpaired electrons are there? 0. Okay. Our last example was chlorine. And again, we already did this. I'm just going to show you what it looks like on your homework. Okay, and then how many unpaired electrons? You click in there and type in 1. The next step is to convert the diagrams into an actual electron configuration that we're writing. So the energy level names, we're going to use those, and then the arrows become a superscript. So 1s, we still use 1s, and then how many arrows you have here becomes the superscript. So 1s with one arrow going up and one arrow going down becomes 1s2. All of this down here becomes 1s2, 2s2, 2p4. So you're just, the numbers tell you how many arrows are in that subscript. So here we go. Here's oxygen. Again, you've already done this. We're just writing the electron configuration down here. I'm going to click in here and write it. So I would write 1s2. And then 2s. 2, and then 2p4. So this is telling me in my first, there are 2. In my first orbital, there are 2 electrons. In my second orbital, there are 2 electrons. In my 2p energy level, there are 4 electrons. Okay. Here's the magnesium. Same thing, we're just going to write the electron configuration down here. We have our first one is 1s. There are 2 electrons in there, so let me put that superscript of 2. Then we have 2s. There are 2 electrons in there, so let me write that superscript of 2. Next I have 2p. All of those are filled, so it has a superscript of 6. And finally, there's 3s, which has a superscript of 2. Last but not least, we have draw the orbital diagram and write the electron configuration for chlorine. So same thing, we're just filling in here 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p. How many electrons are in the 3p? There are 5. And we are done. All right, if you guys have any questions on anything from today, please let me know. I'm here to answer them. Have a great day.